Alrighty. So what we're going to do today is we are going to start talking about graphing these more complicated rational functions. Okay? Everything we did yesterday is just kind of the very, very basics, and it's very much just getting an idea of what these graphs look like. What we're going to do today is going to move things around a little bit more. Sometimes we're going to have more than two asymptotes. Okay, and we need to know where all these come from. Now, you are given a bright yellow Frady sheet. Okay, the letters spell out Frady. This is like your security blanket over the next few days. Okay, keep it safe, keep it with you, learn it, okay, and let it help you to figure out all the different parts of a rational function. Okay, you will not be allowed to use it on tests or quizzes, but it is great to help you as you build your confidence and build your strength. So let's kind of go through that Frady sheet just a little bit to get an idea of what's going on. First is the F. The F tells us that the first thing we are always going to do is factor. Okay? We're always going to do this first, and we're always going to do this by factoring the numerator and the denominator. If any factors cancel out, we're going to create something called a hole. We are not going to graph any holes today. That's going to be what we graph on Thursday. So you don't need to worry about the holes today. Okay? But we are still going to factor first if we can. The next thing we're going to learn how to find are the roots. What's another word for roots? Zeros, solutions, and what'd you say, Hayden? X-intercepts. Good. So anytime we find roots, what we're doing is finding the x-intercepts. Well, what is the y value when you have an x-intercept? Yeah, the y value of every x-intercept is 0. So would you agree if we have a fraction, if we have a rational function, a polynomial over another polynomial, the only way that's going to be 0 is if we have 0 over something, right? That's the only way we're going to get 0. So the way we are going to do this is we are going to set the numerator equal to 0 to find any of our roots. Because all we really care about is the numerator being 0. So in order to find your roots, you're going to always set the numerator equal to 0. And you're always going to write your answer as an ordered pair, number, comma, 0. Now, this is a really, really important part. Your graph must pass through your roots. And you cannot ever, ever, ever cross the x-axis anywhere else. You can never create a root. Okay? You can never create a new x-intercept. And I promise it's going to make more sense when we put it into place, but we need to go through it just a little bit before we actually start it. Okay? All right. Vertical asymptotes are what we're going to talk about next. Vertical asymptotes represent anywhere where the graph is undefined. Okay? Anywhere the graph is undefined. What would make a function, or what do we know makes a function undefined? Think about these. We're talking about rational functions, so we're talking about fractions. A denominator equal to 0. So these are where the graph is undefined because the denominator can never equal 0, right? Because we can never divide by 0. So to find our vertical asymptotes, you are going to always set your denominator equal to 0. To find vertical asymptotes, you're going to set your denominator equal to 0. Okay? T is going to stand for 2, and it stands for 2 different T's. Tangent and together. Okay? So let's talk about what that means. These tangent and together are going to come up anytime you have a squared factor. Now remember, we practiced factors a lot the week before spring break, right? So I know that a factor is something like x minus 3, right? So if that factor is squared, it's going to create a tangent or a together. What would be another example of a squared factor? Any squared factor. Yep, x plus 6, the quantity squared. Could x squared be just a squared factor? If it's just x squared by itself? Yeah. What about, though, like x squared plus 3? Is that a squared factor? No, because that's not a factor, right? So it's got to be a factor all by itself. Okay. Anytime you have a squared factor in the numerator, so for example, if I had x plus 1 squared over, I don't really care, okay? If I had x plus 1 squared in the numerator, that's going to create a tangent. And really what it's going to create is a tangent root. A tangent root. So what that means is at the root, if I set this numerator equal to 0, I'd have x plus 1 equals 0. So I would have a root at negative 1. Instead of going through that root, like this, I'm going to go tangent to that root. So I'm going to hit it, and I'm going to bounce off, kind of like a parabola. Okay? It's kind of like when your vertex is on your x-axis, okay, of a parabola. Okay, so like I said, the tangent root means we hit the axis and bounce off. If there's no squared, you're just going to go through, okay? That's if you have a squared factor in the numerator. If you have a squared factor in the denominator, so if we have something over x plus 1 squared, what that's going to do is create a together asymptote. Okay, so think about all those graphs we graphed yesterday. They always went opposite directions at the vertical asymptote. Would y'all agree with that? One side of the vertical asymptote always went up and the other side went down, right? We have the two opposite pieces. If you have a squared factor in the denominator, what that's going to create is at that vertical asymptote of x equals negative 1, your graph is going to come on both sides of the asymptote is going to be going in the same direction. So either both sides are going to be going down or both sides are going to be going up. And that's what we mean by coming together at the asymptote. All other asymptotes are going to split. One side's going to be down and one side's going to be up. The way we figure out which side's up, which side's down is all going to depend on our other things, the roots and the y-intercepts. Okay? All right, let's go to the back. The E in Frady stands for the end behavior of the graph. End behavior of the graph. When we talk about end behavior, we are going to be talking about how the graph looks very far on the ends as x approaches positive infinity and as x approaches negative infinity. So we are really talking about the ends of the graph, not what's happening in the middle. Okay? This helps us define our horizontal asymptotes, which tell us about as x gets really big towards positive infinity, and as x gets really, really small towards negative infinity. Notice, horizontal asymptotes can be crossed, you might add, in the middle of the graph. Because really what horizontal asymptotes are there to do are to tell us about the ends of the graph. Okay, the way we're going to decide how to draw our horizontal asymptote is using the degree of the top and of the bottom. Okay, remember, what do you remember about the word degree? We defined that a couple days ago. Does anyone remember? I guess it was like a week ago at this point, but I don't remember. All right, the degree, you need to definitely know this word. The degree is the highest power of the polynomial. The degree is the highest power of the polynomial. So if I had, you don't have to write this down, but if I had x squared plus 2 over 3x cubed minus 1, what's the degree of the numerator? 2, because it's the highest power of the numerator. Okay, so the degree of the numerator would be 2. What's the degree of the denominator? 3, for that 3 right there. So do you see we're looking at the powers? Okay. All right, so there's 3 cases. If the degree on the numerator is higher than the degree on the denominator, there is no horizontal asymptote. There's what's called a slant asymptote, which you'll learn about in pre-calc. Okay? If the degree on the numerator is lower than the degree on the denominator, the horizontal asymptote is y equals 0. If the degrees are the same, we take the leading coefficients of our polynomials. And that's the number in front of the first term. So this leading coefficient would be a 1. And what would this leading coefficient be? 3, the number in front. Okay? So these are kind of hard to remember. So here are 2 different, or here's the way that I use. If the degree is high over low, the answer is no, which means we have no horizontal asymptote. If the degree is low over high, 0 equals y. Okay, so that's our y equals 0. If the degrees are the same, play the coefficient game. So take your leading coefficient over your other one. That's the one I use the most. The other one on the bottom, definitely you can use it if that makes more sense to you. You can have Bobo. If it's bigger on the bottom, if the degree is bigger on the bottom, you've got O, y equals 0. Or you can use Botan. Bigger on top, you get none. It doesn't tell you if they're the same. You've got to remember what to do with that. Okay, so just kind of think, we'll get to used to which ones make more sense. All right, last but certainly not least is the y. And Frady, in order to find our y-intercept, this is pretty straightforward. How do we always find a y-intercept? Put in 0 for x, so that's exactly what we're going to do here. Okay? I want you to write yourself one big note at the bottom of your Rady sheet. I want you to always, every single time, after you graph, I want you to check that you have graphed a function. So check your vertical line test to make sure you graphed a function. Every single thing we graph in this unit is a function. So it must always, always, always pass the vertical line test. You can't have 2 pieces on top of each other. Okay? All right, so that's a lot of talking, I know, without a lot of application. So let's try it. Okay, so have your yellow sheet right out next to you and switch to the white sheet. All right, so just a refresher. Rational function is always going to be in the form f of x over g of x. F of x and g of x are both polynomials. But there's a requirement of the denominator. What do you remember? Okay, true, the denominator can't equal 0. What about the degree of the denominator, though, in order for it to actually be a rational function? The degree has to be, has to be greater than or equal to 1 of the denominator. And remember, we said degree is the highest power. Okay? The denominator has to have a degree greater than or equal to 1. So, as we said, we will use Frady to help us organize our information when graphing, but there will be no holes. We won't have to find any holes today. Okay? The 4 most important things that I'm going to ask you when we graph a rational function that you're going to have to tell me every single time are the roots, the vertical asymptotes, horizontal asymptotes, and the y-intercept. Okay? Often I will also ask you for the domain and range, but not every single time. Okay? All right, so let's give it a try. To find our roots, what does our helpful sheet tell us to do? Good. To find our roots, we're going to set the numerator equal to 0. All right, well, what is our numerator of this polynomial? 5. All right, well, when does 5 equal 0? Never. Yep, 5 never equals 0. So does this rational function have any roots? No. This rational function has no roots, so remember you can say none, or you can say DNE for does not exist. Don't just leave it blank, okay? You have to give me none or DNE. All right, vertical asymptotes. That's the A in Frady. Okay, so your vertical asymptotes, how do we find those? Good. Set the denominator equal to 0. All right. What's our denominator? Good. So take your whole denominator, x minus 1, and set it equal to 0. When x minus 1 equals 0, what does x equal? 1. So that is the equation of your vertical asymptote. If you want to graph it now, you can, or you can graph it after we do the others. All right, horizontal asymptotes. Anytime you're talking about horizontal asymptotes, you are talking about the end behavior. Talking about what happens at the very ends of your graph. So that's when we look at the degrees. Okay, so we're on the back using the E on your Frady sheet. Look at the degrees of your rational function. So what you want to kind of think of is you can kind of think of this as y equals 5x to what power? What power would that x be raised to? 0. Good. 5x to the 0 power over x. What power is this x raised to? The first power. Minus 1. So you might have to kind of think about what the degrees are. So what would the degree on top be? If we have 5x to the 0 power, what's the degree on top? 0. So degree on top is equal to 0. What's the degree on the bottom? Nope. What's the degree of the x? What's the power of the x? 1. So the degree on the bottom is 1. All right. Because there's no x up here. And x to the 0 power is just 1. So that's like 5 times 1. Okay? All right, so this is a degree of 0 over a degree of 1. Well, which case is that? Is that high over low, low over high, or the same? Low over high. So low over high, 0 equals y. So we have a horizontal asymptote at y equals 0. That's that rhyme. Low over high, 0 equals y. All right, how do we find the y-intercept? Good, plug in 0 for x. All right, so that would give us y is equal to 5 over 0 minus 1. So y equals -5, right? And how do I need to write my y-intercept? As a point. Good. So it's not y equals -5. It's the point what? 0, -5. Intercepts and roots are always points. Asymptotes are always equations. Okay. So now we're going to plot these 4 things before we talk about the t's. Okay. So let's plot. We don't have any roots to plot. We do have a vertical asymptote at x equals 1. So remember from yesterday, you're going to draw in a vertical line, dashed, and you need to label it with your equation. Okay, we have a horizontal asymptote at y equals 0. And then we have a y-intercept at 0, -5. Okay, that is all the information we've gathered, and that's all we're going to really need to draw our graph. Okay, so what we want to do is it says before you graph, meaning before you draw in the rest of your curve, think using your t. Are there any tangent or togethers? So really what you're looking for, are there any squared factors? No, because we just have 5 on top, which is just a single factor, and x minus 1, which is a single factor. So we don't need any square factors. Or we don't have any square factors. So we don't have any tangent roots. Well, we don't have any roots at all, right? And we don't have any together asymptotes. So that means if this is not a together asymptote, this is a split asymptote, which means one side has to go up and one side has to go down. All right, think about what's the only real way we can draw this if we can never cross our vertical asymptote. Would you agree that we would have to kind of fill this in this section using our asymptotes as magnets? We get pulled towards each asymptote. So we're going to kind of just draw in our curve. Make sure you go through your y-intercept and get pulled towards your other asymptote. Your asymptotes are like your guides. Okay. Now this is why we had to know that this was a split asymptote. Because I have 2 options. I could be down in this quadrant or I could be up in this quadrant. But if I was down here, that would create a together asymptote because I'd have down on both sides. Did y'all see that? So I have to go up here. You just kind of sketch it in using your asymptotes as your guides. There's no specific points you have to plot. These are all going to be sketches. If you graphed them on your calculator, they probably would look a little bit different. Because I don't know that I go through this 0.32. I'm just sketching. Okay? All right. What would the approximate domain be of this function? Based on our sketch. Good. Union 1 to infinity. And what would our range be? Good. Negative infinity to 0, union 0 to infinity. Questions? Probably a lot, and that's okay. Right? We're going to do it a couple more times. Get it a little more comfortable. Okay. Let's look at number 2. Okay, first thing I check is there anything that needs to be factored in my rational function. Anything need to be factored? Nope. All right, so then I dive in and I find my roots. How do I find my roots? Good. Numerator equal to 0. So x plus 2 equals 0. So x equals -2. How do I write that so it represents a root? Very good. -2, 0. All right. Vertical asymptotes. That tells us to use the A in our Frady, so it's a vertical asymptote. We're figuring out where the function's undefined, so we do what? Good. Denominator equal to 0. So x minus 1 equals 0. So x equals 1. So on the vertical line, x equals 1, we have a vertical asymptote. Okay? All right, horizontal asymptotes mean we're talking about the end behavior of the graph. What happens as x gets really big and what happens as x gets really, really small. So to look at those, what do we look at? The degrees. Okay. So we're going to take the degree of the top and put it over the degree of the bottom. What's the degree of the top? 1. There's a 1 right there. Yeah? So the degree on top is 1. What's the degree on bottom? Also 1. All right. The degrees are the same. Play the coefficient game. So that tells me we need to do y equals a over b. A is the leading coefficient of the numerator. So yeah, so what number's in front of our x here? You see how it's a 1 out here, the coefficient? So that's a 1 over, what's the leading coefficient here? But those are different ones than the degrees, right? Okay. So 1 over 1 would just give us the horizontal asymptote y equals 1. All right, and what about y-intercept? What do we do? Good, plug in 0 for x. So 0 plus 2 over 0 minus 1. What's that going to give us? -2. So I write it as my ordered pair, 0, -2. All right, before we get to the t, plot these 4 things. So plot your asymptotes. Make sure every time you graph an asymptote, you are labeling it with its equation. And you are drawing it with a dotted line. All right, so does everyone have these 4 things plotted? Okay. Notice I have 2 points on the same side of my vertical asymptote. I have to connect those points. They're going to have to go together. Don't necessarily use a straight line. Try and make it kind of curvy. But just know in your head, those 2 points are going to have to go together. Everyone okay with that? Now, we kind of got to decide where else to go. That's when we think about the t's. Are there any squared factors here? No. There's no square factors. So that means I cannot bounce down from my root. I have to go through my root and towards my asymptote. Because you only bounce off or become tangent when you've got a squared factor in the numerator. Right? Where's the only way it really makes sense to go from here? Down. I can't go up. Do you see if I went up how I would cross the x-axis? And that would create an x-intercept, and you are never, ever, ever allowed to create an x-intercept. Okay? Now, do we have any squared factors in the denominator to create a together asymptote? No. So this is a split asymptote, which means if this side goes down, what does the other side have to do? Go up. What would happen if you did sketch in down here? What would you create? You'd create it together. What else would you create? Yeah, you see how you would have to cross the x-axis? And that's a rule you want to keep repeating in your head. I can never create an x-intercept. I can never create an x-intercept. Okay, that'll keep you from making lots of errors. All right, did we graph a function? Do the green parts of our graph make up a function? Yep. All right, what would the domain be? Negative infinity to 1, union 1 to infinity. And what would the range be? Same thing. Yep. Negative infinity to 1, union 1 to infinity. All right. Let's go to the next page. All right. Before we start filling out our information, you're going to factor anything that can be factored because we always do the F first. So the numerator is good. How would the denominator factor? Good. X plus 5 times x minus 1. Now, sometimes we're going to want to use the non-factored version. And sometimes we're going to want to use the factored version. It just depends on what we're trying to find. Okay? So you want to make sure you're paying attention to both versions. All right. How do we find our roots? Good. Numerator equals to 0, so x plus 3 equals 0. So x equals negative 3. And how do I write it? Negative 3, 0. It's our x-intercept. All right, for this function, this time we're not only going to have one vertical asymptote because we have two factors that could be equal to 0. So we're going to have two different vertical asymptotes. So you're going to set each factor of your denominator equal to 0. X plus 5 equals 0, and x minus 1 equals 0. That's because that original polynomial, x squared plus 4x minus 5, has two answers that would make it 0. So what are our two vertical asymptotes going to be? X equals negative 5, and x equals 1. Everyone okay with that? All right, horizontal asymptote means we're talking about the end behavior, so we have to look at the degree. So is the factored version going to help us, or is the non-factored version? The non-factor, because you have to look at it as a polynomial, not as individual factors. Okay, so what is the degree of the numerator? 1, because of that one right there. So the degree of the numerator is 1 over the degree of the denominator, which is 2. So what is our horizontal asymptote? Good. Because we've got a low degree over a high degree. Low over high, 0 equals y. All right. y-intercept. Which form is probably best to find our y-intercept? The which one? The non-factored one, because anything with an x in it is going to get to go away. So I'm going to plug into the non-factored one. So 0 plus 3 over 0 plus 0 minus 5. Because isn't 4 times 0, 0? And isn't x 0 squared 0? So these can all go away. So what is our y-intercept going to be? Negative 3 over 5, and we write it as a point. So 0, comma, negative 3/5. Okay with that? All right, plot these four things. Now, right away when you plot these, something probably looks a little bit weird. What looks a little bit weird? Okay, there's 2 vertical asymptotes. That's definitely weird. Notice this root, though. What's it on? It's on our horizontal asymptote. Is that allowed? Yes. Flip back if you need to see that. You are allowed to cross horizontal asymptotes. Okay, in the middle, weird stuff happens. These horizontal asymptotes are for as x gets really big towards infinity and as x gets really small towards negative infinity. Okay, so in the middle, it is okay. Are you ever allowed to cross a vertical asymptote? Never, ever, 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 ever. Okay, so there are going to have to be 3 separate pieces of this graph. There's not going to be just 2. There's going to be 3. Now, one thing I know I need to do, because these 2 points are in the same section, between the same vertical asymptotes, I have to go ahead and connect those 2. I know they're going to connect. And then I got to figure out what else happens. So I look at this root of negative 3. Did that root come from a squared factor on top? No, it came from just x plus 3, right? So there's no tangent root. So that would, I can't go back down. I have to go up. And what about from my y-intercept? What would I have create if I go up? What would I cross that I'm not supposed to? The x-axis, which I can't do, right? I can't create an x-intercept. I also can't cross a horizontal asymptote just because I want to. I have to need to, right? So from your y-intercept, which way are you going to have to go? Down. All right, side. How'd I know this side had to go up? Because if I wanted to hit at negative 3 and bounce off, that's what we call the tangent root. And that only happens when we have a squared factor in the numerator. Okay, but the factor that gave us that root was just x plus 3, so it wasn't squared. So when you have a root that's not squared, you go through it, through the x-axis. Okay, now we got to figure out what's happening on the right and what's happening on the left. So we need to look, do we have any together asymptotes? So to find together asymptotes, we think, are there any squared factors in the denominator? Well, there's an x squared, but is that a factor? No. The factors are x plus 5. That gave us x equals negative 5 and x minus 1. Are either of those squared? No. So both of these asymptotes split. So let's look at x equals -5. We have one side that's already up. So what does the other side have to do? Yeah, down, because we got to split. So we're going to be in this section. All right, now let's look at x equals 1, which we know is also a split asymptote. We have one side that's down, so what's the other side going to have to do? Go up. That is our sketch of this rational function. Okay, domain. For our domain, we're going to have to skip over 2 x values, right? Because we have 2 vertical asymptotes. So our domain is -infinity to -5 union -5 to 1 for this section, union 1 to infinity. You have to skip over the vertical asymptotes. What is your range, though? It's what? It's the whole graph. Why? Yeah, see how the middle section goes in opposite directions? So that middle section covers every single y value. So we know that every single y value is covered. Even though there's a horizontal asymptote here, we actually had to cross it. So our range is all real numbers. Questions? All right, let's do one more. All right, what's the first thing you should do? Factor. Good. Please go ahead and factor that denominator for me. All right, how does the denominator factor? Good. 6 over x minus 2 squared. All right, so now we're going to get to see what happens when we have one of these squared factors. All right, what about our roots? Are we going to have any roots here? No, why not, Hayden? Yeah, there's no x on top. So if I try and set 6 equal to 0, is that ever going to happen? No, so there are no roots. How many vertical asymptotes am I going to have? Yeah, because even if I wrote this as x minus 2 times x minus 2, wouldn't they still give me the same value? Yeah, so our vertical asymptote is at x minus 2 equals 0, which is going to give us x equals 2. Horizontal asymptote. What am I paying attention to there? The degree. What's the degree on top? 0. Good. What's the degree on bottom? 2. So what does that mean? Good. Low over high. 0 equals y. Right? Y-intercept. What do I plug in? X for 0, so 6 over 0 plus 4. So that's going to give us 6/4, which reduces to 3/2. So how do I write that? Good. 0, 3/2. All right. I have a vertical asymptote at x equals 2. And I have a horizontal asymptote at y equals 0. And I have a y-intercept at 0, 3/2, which is 0, 1.5. Okay, do I have any squared factors for my t's? Yeah, where? The denominator. I do have a squared factor in the denominator, so I do have it together. So we're going to be together at what asymptote? What asymptote was created for x minus 2? X equals 2. So at the vertical asymptote of x equals 2, we're going to be together. So you might kind of write that out to yourself. Maybe you just put a T for together, whatever you need. So you know when you draw in at that asymptote, you've got to have your arrows going in the same direction. All right, what piece can we already draw in? What piece do we know? We're going to be in the top right, top left, bottom right. Top left, because we have to use that y-intercept, right? So we have to go towards it. We have to go up. I can't go down from here because that would create an x-intercept, and I don't have any. And I have a together asymptote. So am I going to be on the top right or the bottom right? Top right, because I've got to have my arrows going the same direction. Okay? All right, domain. Good, union 2 to infinity. And what would our range be? 0 to infinity. It's just the top. Okay? All right. Your homework is going to ask you, it might not, it's not spelled out like this, but you are going to be responsible each time for finding the roots, the vertical asymptotes, the horizontal asymptotes, the y-intercepts. The T, you can write it out for your brain, but the T is to help you actually draw the graph. Okay, so that's why it's a think one. Before you graph, think. Okay? All right.